So this is going to be linear relationships, introduction of proportional relationships. It's very straightforward. A lot of it is just reading word problems and graphs and writing equations from it. So this is the first problem. It says Sarah spent the weekend baking muffins for a bake sale. The table shows the number of muffins she baked for the first 3 hours on Sunday. Sarah continued baking at this rate for several more hours on Sunday. Write an equation to represent the number of muffins Sarah baked on Sunday. Okay. So the question is, on Sunday, how many muffins did Sarah bake each hour? Explain your reasoning. Well, she baked 18 muffins per hour, because at 1 hour it's 18, and they said that they continue at this rate. So is this rate at which Sarah baked muffins on Sunday constant? Yes, it's constant because every hour you add an additional 18 muffins. And then writing the equation to represent the number of muffins that Sarah baked on X hours. So your equation would be y equals 18x. You can write plus 0 because she started off with 0 muffins, and then it's 18 muffins per hour, and x represents the number of hours on Sunday. All right, so that's what we're doing today. So we're going to find out a little bit more. So suppose that Sarah also baked 24 muffins on Saturday. So you can use a graph or an equation to represent this. So since you already had 24 muffins, your equation would now be y is equal to 18x plus 24, because 24 is the muffins that were on Saturday, plus the 18 muffins she bakes per hour on Sunday. And this is now would be considered a non-proportional because it doesn't go through the origin. Proportional relationships do go through the origin, and we'll hit more on that throughout this unit. We'll say that more than one time. Okay. So describing how the equation y equals 18x plus 24 represents the total number of muffins Sarah baked over the weekend, and how can you identify the rate of change in the equation? So the 24 is the number 24 muffins that she started with, and then baked 18 muffins each hour. The coefficient, the number in front of the x, will always be your constant rate of change, or what would be called our slope, and you'll learn about that later this week. So the 18 is your rate of change. So there's this problem, and we're going to explore different ways to do this. So it says Joanna had a $10 gift card to spend on an online store. She wants to buy some DVDs that cost $15 each and use a table and a graph to represent on how much Joanna will spend Y in dollars if she uses the gift card to buy X number of DVDs. So here's a table to represent this. And then here's a graph. So looking at the table, what do X and Y represent? So I can look at this graph and see what they represent. So X is an independent, and it is the number of DVDs. Y is dependent, and is the amount that it will cost her. The reason why Y is dependent is because it depends on the number of DVDs you're buying to output the cost. 3 says, how does a verbal description help you create the table? It helps you identify where you start on the table and how much you go up for each DVD. So this is proportional. No, to be proportional needs to go through the origin. And then 5 is, what is the rate of change? So since it's $15 every DVD, it's $15 the rate of change. And is this a linear relationship? Yes, because it's going up in a straight line. Okay, so this is another problem. And it says, use a table and a graph. You don't need to do that. I just need you to write the equation. So it says Liz already read 36 pages of a book. Each day after that, she reads 12 more pages. So the equation would be 12x because each day she reads 12 pages plus the additional 36 pages she read. And that'd be your equation, which you can then make a table and a graph from. Here we have a situation where it says the graph represents the amount that Brad pays his parents back each week for the money he borrowed. Describe the relationship between the number of weeks and the amount he still owes, then write the equation. So what I first want to figure out is where he starts. So he starts right here, which is 45. And that's the reason why this b is 45. And we'll get more into this equation of y equals mx plus b and it's describing it. So then it's going down. So that's the reason why the coefficient right here is a negative. And at 1, it went down to 42. So it means it went down 3 every time. So it's going down 3 every time. So my equation would be y equals negative 3x plus 45. And you can also rewrite it as y equals 45 minus 3x. So that way you're taking it away from the 45. So the two quantities have a linear relationship, hence they create a straight line. The amount decreases by 3 each week, as we just discussed. The rate of change per week is 3 because on the graph it goes down by 3 each week. The line meets the y-axis at 45, which represents B in the equation. And then 45 represents the money borrowed from his parents, so Brad has to pay back $3 per week. So then this one says Elijah is 300 miles from home and driving at a constant rate of speed. So this is the 300 miles. This is the start, and that's the reason why this is right here. And then at 1 hour, it goes down to 50. So I mean, he's going down 50 miles an hour. So you can write it as y equals 50x plus 300, or you can write it as y equals 300 minus 50x. So he goes 50 miles. He's decreasing 50 miles per hour in a sense of like distance remaining. So he's driving basically 50 miles an hour. So this one is a landscaping, and you need to write the equation. So you look at your starting spot. So he starts at 150, and then at 1, he gets at 200. And then at 2, it's at 250. So each number of hours he works, he makes an additional $50. So he charges $150 to start with, and then an additional $50 per hour, and so on. And that is what we're basically talking about. It's just a really quick introduction of the formula y equals mx plus b. We'll get more into what the m and more into what the b is. Okay? Thanks, guys.